Let's continue our study of volume and surface area by finding the volume of an irregular shape. Notice here we have a cylinder and a hemisphere, half of a sphere, attached. So we're going to have to break this problem up into the cylinder and the hemisphere. First, the cylinder. Here's the formula for the volume of a cylinder. We can see that the radius is 3 and the height is 5. So by simply plugging this in and doing the math, we'll get the volume of the cylinder portion of this shape. Now the hemisphere. If we had a full sphere, which we don't, the volume would be 4/3 pi r cubed. But since we have a hemisphere, we're going to have half of that. Half of 4/3 is 2/3, and so this formula becomes 2/3 pi r cubed. And that is the volume formula for a hemisphere. Now plugging in the fact that the radius is 3 and doing the math gives us the volume for that. Now that we've done each portion of the shape separately, of course we want the total volume, so we're going to take those two numbers and add them together. Notice both terms have a pi in them, so in some sense they are like terms and can be added together, and the volume here would be 63 pi. They don't specify which kind of units, but remember, volume is always measured in cubic units, so we have to say cubic units in our answer. Now let's take the same shape and find the surface area. Remember, the surface area means the number of square units on the outside of the figure. Again, we're going to have to break this up into a cylinder and a hemisphere, but it's going to be a little bit trickier this time. Now, if we had a full cylinder, which in some sense we don't in the surface area way because the top of the cylinder is covered by the hemisphere, this would be the formula for the surface area of a full cylinder. But let's dive into where this formula came from for just a moment. Here's a generic cylinder. I'm no longer talking about our particular problem. A cylinder is broken up into essentially 3 parts. The top, which is a circle and has area pi r squared. The bottom, which is a circle and also has area pi r squared. And the sides, also called the lateral surface area. And that has a surface area of 2 pi rh. And this is where the whole formula for a cylinder comes from. It basically is the green part plus the red and the blue combined. But in our case, let's not forget that there's a hemisphere sitting on top. And so that the red circle, or one of the circles, is not actually on the exterior of the shape. And so we can't count that pi r squared. The parts of the cylinder that are exposed to the outside are the lateral surface area and the bottom. And so the green and the blue added together gives us the formula for the surface area of the part of the cylinder, at least that we care about. So notice you can't use the full formula for a cylinder on this problem because one of the portions of the surface area is covered up by the hemisphere. Tricky. Putting in all the time signs and the fact that the radius is 3 and the height is 5 allows us to eventually get an answer for the portion of the surface area of the cylinder that is actually exposed to the outside, which again excludes the circle at the top covered by the hemisphere. Now on to the hemisphere. If we had a full sphere, the surface area would be 4 pi r squared, but since we have a hemisphere, we have half of that, which is 2 pi r squared. That's the surface area formula for a hemisphere. Plugging in the fact that the radius is 3 and doing all the math, then putting that answer with the exposed surface of the cylinder allows us to add them both together and get the total surface area of this figure. Now remember, surface area is area and therefore measured in square units. So make sure you put square units not cubic units for this answer.